Hello friends. Very good evening to everybody. We are meeting once again for a short tutorial 7 on relay setting calculations. We will be solving one example, one numerical on settings of directional overcurrent relays for a parallel feeder fed from single end. That is, on one end there is a source and on second end there is a load. I hope everybody knows that parallel feeders are quite common in the field practices. The rows of towers is there. So on left side there will be RYB one feeder, on right side RYB second feeder. If on one feeder you can transmit 100 megawatt, then on two feeders you can transmit 200 megawatts from one point to the other, from one CT to another. That means double the power can be transmitted without any extra cost of transmission towers. No doubt, cost of insulators and conductor is added, but tower cost is saved. That is why the parallel feeders are very common. But when it comes to parallel feeders, the relay setting exercise is little tricky, little complicated, and as we have been adding complicacies in tutorials one by one, in first tutorial we simply calculated for a radial feeder fed from one end, right, for phase overcurrent relays. In tutorial 2 we calculated the relay settings for ground relays, ground overcurrent relays, for a radial feeder fed from one end, but having a simple network without transformer, right. In next tutorial we carried out an exercise for calculating the settings of ground overcurrent relays for a power system network in which the power transformer is there, dy delta y power transformer is there. So now we come to parallel feeder, in which obviously we will have to use directional overcurrent relay, right? Because the simple overcurrent relay cannot be useful. I mean, simple overcurrent relay alone cannot be used, and you have to add the directional sense. So that is what we will be trying to do in this tutorial class. So friends, moving to the next slide. This power system network, as it is opening to you slowly, the decorative work has been done by Maitri Velani of Techno Art Studio. So with a big thanks and a lot of appreciation to Maitri, we are starting this tutorial class. You see, 120 megawatt 11 kV generators are there, two generators. One 150 MVA transformer, sorry, two 250, 150 MVA GTs 11 by 132 kV are there. Two generator breakers, 1 and 2 are there. Two CTs for the generators are there. The ratio probably has been forgotten. It is 1000 bar 1 only. So 1000 bar 1 CT ratio, and the relays are R1 and R2. Then there is a bus A, from which from bus A to bus V parallel feeder is running. All the four CTs are 1000 bar 1 ampere. Relays are R3, R4, R5, R6. R7 is a relay on line BC, 500 bar 1 ampere CT. Beyond that CT, there is a 132 by 66 kV, 100 MVA transformer. And then from bus C, 66 kV outgoing feeders are going. So we would like to consider this network. You can obviously understand and rather appreciate that if there is a fault on line AB, the upper line AB, I am telling upper because here it is in upper. There is nothing like upper lower. It is left right, right? But here if I say upper, then on the upper line AB, if there is a fault, then fault current will pass from R3 to fault. And another route will be R4, R6, R5 and fault. So R6 and R5 both will operate for that fault because that fault current is same. If you want that R6 should not operate and R5 should operate, and obviously R5 only should operate because fault is in the upper line, R3 and R5 should operate, breaker 3 and 5 should trip, breaker 4 and 6 should not trip, R6 should not operate. Therefore, you see, if you are using simple overcurrent relays, then time of operation of R6 has to be higher than time of operation of R5. But that you can't just do because if there is a fault on lower line, that is another line AB, then the fault current will be flowing from R3, R5, R6 and fault. Then you would say that time of operation of R5 should be more than R6. That is just not possible. Therefore, time of operation, or so to say TMS of R5 and R6, which are located on the same bus, are always same. And if you want only one relay to operate, then R5 and R6 have to be added with one more discriminative sense, that is the direction. That is R5 and R6 are directional relays with the direction away from bus B. With the direction away from bus B, right? R1, R2, R3, R4, R7 need not be directional because if you take any fault, that is upper line AB, lower line AB or line BC, the fault current is not going to have two different directions. You see, the fault current is going to flow from left to right only. Whereas for R5 and R6, in one case it is left to right, in another case it is right to left. Therefore, R5 and R6 are directional. The operative direction away from bus B, right? Operative direction away from bus B. R1, R2, R3, R4, R7 are non-directional. The fault currents are, fault current for three-phase faults are given as on bus A it is 1000 MVA, that is fault level in MVA. On bus B 700 MVA and on bus C 408 MVA. So this is, my friend, our example, our numerical. Going further, the power system network description is like this, that the bracketed figures are showing the fault levels for triple line fault on concerned bus, as we have already told. Relays used are IDMT overcurrent and earth fault relays, rated for 1 ampere with a setting range for overcurrent units 50 to 200% of 1 ampere in 7 equal steps. And overcurrent earth units, the setting range is 10 to 40% of 1 ampere in 7 equal steps. All relays R1 to R7 are wired for 3 overcurrent and 1 earth fault scheme, very obviously. Both phase and ground units at relaying point R7 are set at TMS equal to 0.25. This is all data that is given. Relays R1, R2, R3, R4 are voltage controlled overcurrent relays. such that their flux setting reduces to 40% of the set value automatically if voltage collapses below 70% of rated value. If voltage is more than 70%, then the set value is retained. For R5, R6 and R7, they are not voltage controlled overcurrent relays. The excitation currents of all cities is 0.03 ampere. For calculating the TMS for earth fault units, the ground units, we need the earth fault current. So they are also given at bus A 5014 ampere, at bus B 3288 ampere, and at bus C 4445 ampere. So you have to assume suitable discrimination time margin, which we usually assume 0.25 second. You have to determine the flux setting and time settings of all phase and ground relays shown in figure. Right now here we are not going in for high set instantaneous units as of now. Right? We slowly develop the subject of protection of transmission line using overcurrent and earth fault relays. So we have gone in for some, this is the 7th tutorial, and I think by 11 tutorial classes, we will be ending the main points of the power system protection. No doubt, quite a lot much of theory is not covered. Many exercises, many examples which you have to calculate for yourself to know whether you have known the subject or not, right? All these things are remnant, but for that you will have to subscribe module 3, which is already uploaded on mobile app Adapt Me, which can be downloaded from Google Play Store. But this much is free of cost, my friends, to let you know, to let you know the subject, and to share my knowledge of some 43 years with you. So this is the example. These are the details. Going further, what is the solution? Relays R5 and R6 are directional overcurrent relays. Direction away from the bus, as I was telling to you, right? So here the direction shown is just for showing that it is a directional relay. So arrowhead, single-headed arrowhead is just for showing that it is a directional relay, but operative direction is away from bus B, right? As that is what we have seen, away from bus B. That is what we have seen for R5 and R6, away from bus B, right? So R5 and R6 directional, R1, R2, R3, R4, R7 are non-directional, usually shown by double-headed arrows, right? So this is how our solution starts. The next slide is on solution of flux settings of phase relays. How do we calculate the flux setting of phase relays? We will not carry out the exercise of ground relays in this tutorial. That will take in next tutorial, because I want to restrict my video time to about 30 minutes, because to go through and to hear the big long video, people are getting tired, people have less time also. So you just get half an hour and just see through the video and you learn many things. So we start with the last relay towards load, as we have been doing, right? R7 is the last relay, so flux 7 of R7 will be decided based on rated primary current of 100 MVA transformer. Yes, please let us see 100 MVA transformer, 100 MVA. R7 flux setting is based on primary side of 100 MVA transformer, right? So 100 MVA transformer, primary side of 100 MVA transformer. 100 MVA upon root 3 into 132, right? Upon 500, because 500 bar 1 is the CT ratio R7. Let us check 500 bar 1. 500 bar 1 is the CT ratio R7. So divided by 500. So divided by 500 and into 10 raised to 3, because I have to convert from K kiloampere to ampere, right? So that, and into 100 gives me percentage. So that gives me 87.47%. And if right now I assume that I have got the conventional relays 50 to 200% in 7 equal steps as we have started, 50, 75, 100, 125, 150, 175, 200. Therefore, we select 100%, right? So, PS of R7 is selected as 100%. Now, R5, R6 is directional, right? So, they are not looking towards R7. So, R3 and R4 will back up R7 and not R5, R6. So, once again, to see the figure, friends, so that you are sure, R3 and R4 will back up R7, not R5, R6, because R5 and R6 are looking away from the bus towards bus A. They are not looking towards R7. Try to understand, right? So, this R7, R3, R4 will back up R7. So, PS of R3, R4 for grading with the relay R7. So, will be 75% of, will be 75%. 1.3 divided by 1.05 principle, that is PS of R3, R4 should be great R3 or R4. I am telling. Why I am telling R3 or R4? Because R3 and R4 are same. Our system is symmetrical. You see, both generators are 120 megawatt, both GTs are 150 MVA, both transmission lines are identical. Therefore, whatever is the flux setting of R3, same is R4. Whatever is flux setting of R5, same R6. Whatever is flux setting R1, same R2. So, R3 oblique R4 I am writing, that is R3 or R4. R3 or R4 will be higher than 1.3 divided by 1.05 of 100% of 500 ampere. 100% of 1 ampere, or in primary terms 500 ampere. So, 1.3 divided by 1.05 of 500 will lead me to somewhere around 650 or little less than 650, and 650 divided by 1000, because R3, R4, my dear friends, R3, R4 is 1000 bar 1, therefore divided by 1000. R3, R4 is 1000, therefore 650 divided by 1000, some 650%. Therefore, I have to select 75% next available setting. If you look from full load current per feeder, then in one feeder 150 MVA is passing, in another feeder 150 MVA is passing. So 150 divided by root 3 into 132 into 10 raised to 3 for converting to amperes from kiloamperes, it gives me 656 amperes. So 656 divided by 1000 also gives me 75%. 65.6% means 75%. So lookingly it seems, on first sight, it seems that 75% both ways, 1.3 divided by 1.05 principle of or rated current principle, 75% is the flux setting of R3 or R4. But my dear friend, this would have been so should we have used numerical relay. But as right now we are not thinking about numerical relay, that will not be the case, because if one of the feeder trips due to fault, in that feeder, right? Out of two parallel feeders. That means there is one line contingency. Or say one feeder is under maintenance. Then the other feeder will be loaded with double the current that we have calculated. Not 656, but double the current. Right? Now 656 into double means 1312 ampere will pass. 1312 divided by 1000 is 1.312. That is 131%. But my setting is 75% of 1000, that is 750 amperes. And 750, 1312 is more than 750. Therefore, other feeder which is LD, you see, fault was in one feeder that has tripped correctly, but the other feeder that is LD will also trip, which is really wrong in case of protection, because protective relaying requirement says that healthy feeder should not trip. So you will have to set R3, R4 based on one line contingency. That means you will have to set them for 150 into 300 MVA basis. 300 MVA basis is 1312 ampere, and that gives me 131.2%, and therefore my setting will be 150%. So R3 or R4 are set at 150%. Now what if you see this parallel feeder once again? Parallel feeder once again, if you see this parallel feeder, right? If you see this parallel feeder, R3, R4 are backing up R7, that is correct. But R3 backs up R6. Because if there is a fault in lower feeder, then current will pass R3, R5, R6. R5 will not operate because it is directional. Fault current is passing from left to right. And R5 operative direction is from right to left. Therefore, R5 will not operate, but R3 will operate. But R3 has to give backup to R6. Should R6 fail, R3 will give backup. R3 will give backup. And if R5 fails, R4 will give backup. Right. If R5 fails, then R4 will give backup. That is, if there is a fault in upper feeder, R5 should operate, R6 will not operate because it is directional, but R4 will give backup. Therefore, what is my requirement? That plug setting of R3 should be higher than 1.3 divided by 1.05 of plug setting of R6, or other way around. Plug setting of R4 should be higher than 1.3 divided by 1.05 of R5. If I consider that consideration, my dear friends, if I consider that consideration, plug setting of R3 or R4 should be higher than 1.3 divided by 1.05 of plug setting of R6 or R5. That means reverse way, because I am knowing R3, R4, not knowing R6, R5. Therefore, plug setting of R5 or R6, right, should be less than 1.05 by 1.3. That greater than will turn to less than, and 1.05 by 1.3. So 1.05 by 1.3 PS of R3 is 150% of 1000, that is 1500. That gives me 1211.53 or 121.15%. It should be less than that. Therefore, R5 or R6 are set at 100%. And on the similar lines, plug setting of R1, R2 should be higher than 1.3 divided by 1.05 of R3, R4. That takes me to 200%. So I have found out the plug setting of all relays R1 to R7. Right? All relays plug settings are found out. Now I have to go for time settings. Now for time settings, for plug setting, worst condition was one line contingency. For time setting, worst condition is highest fault current. And highest fault current is when both the feeders are on, because when both the feeders are on, the parallel combination of impedance is, say one is Z, another is Z, then the parallel combination is Z by 2. So induced EMF divided by Z by 2, current will be high. So highest current is both the feeders on. So for time setting, worst consideration is both the feeders on. highest fault current. So we will consider both the feeders on, right? So for that we will do R3, R7 coordinate, because R3 or R4 is backing up R7. So R3, R7 coordination we will be doing. And when we do R3, R7 coordination, we have to consider fault level 700 MVA, my dear friends. Let me check up. I have to consider 700 MVA because it is on bus B, just beyond R7, that is just beyond breaker 7. If on bus B it is 700 MVA, just after breaker 7 it may be 699 or 698 MVA. So practically 700 MVA, right? So worst fault current is 700 MVA. So R3 and R7 I have to consider 700 MVA. Considering 700 MVA, what I do for time setting 700 MVA, plug setting multiplier of R7, 700 into 10 raised to 3 root 3, 132, 500 bar 1 is CT ratio. So 6.12. That means top of R7 is 3 upon log 6.12 into 0.25, which is given. TMS of R7 0.25 is given in data. So time of operation of R7 is 0.9532. Here we are not considering instantaneous unit. So we stop at 9.9532. Right? Had instantaneous unit been given, then we would have considered it. But in some other example, we may consider. Therefore, top of R3 is 0.25 more. That is the relay that is backing up, 1.203. So what is PSM of R3? Now R3, what happens? That 700 MVA, my dear friends, once again looking to that figure, 700 MVA is divided into two parts because two parallel lines is there. So two parts. So that divided by 2. So when I go for TMS, I divide by 2. Therefore, PSM of R3 700 into 10 raised to 3 root 3 into 132. 2, that is divided by 2 factor is coming, and 1500 because 150% of 1000 in primary terms 1500 is plug setting. 0.4 because it is voltage controlled overcurrent relay, the fault has occurred. R1, R2, R3, R4 are voltage controlled overcurrent relay. Therefore my PSM is 2.55, right? So this is what I have written in red. This is because fault current is divided into two equal parts, and relay R3 is a voltage controlled overcurrent relay, the plug setting of which is reduced to 40% of set value during fault condition. Right. So going further, TMS of R3 what? 1.203. 1.203 is the time of operation of R3. So into log 10, 2.55, which is the PSM divided by 3. That takes me to 0.1631. Going in further 0.05 step, I have to set TMS of R3 or R4 at 0.2. Now I have to do R3, R6 coordination, my dear friend, because I have to go back to R3, R6 coordination. Try to understand. That means R6 should operate first, R3 should give backup, R3 should operate 0.25 second later than R6, but now time of operation of R3 is available, therefore R6 should operate 0.25 second earlier than R3. And with reference to that, I have to decide TMS of R3, my dear friends. So I go in for TMS of R3 with that, right? So R3, R6 coordinate, fault current will be same, 700 MVA. For R3, my PSM is also same, 2.55. But my TMS is not 0.1631, which is calculated. I have set at 0.2. So the actual time of operation is 1.475 seconds. Top of R6 minus 0.25, 1.226 minus 0.25, 1.226, right? Try to understand. And PSM of R6, it is not voltage controlled. Therefore, 700 into 10 raised to 3, root 3 into 132, 2. 2 factor is coming once again. See, because there also it is divided into 2 parts, right? Therefore, 2 factor is coming. And 1000 bar 1 is the CT ratio. 1.53 is the PSM. TMS of R6 is 1.226 time requirement into log 10 1.53 divided by 3. TMS should be less than this, my dear friend, not more than this. Try to understand. And therefore, I go for 0.05. R6 is 0.05. Same is R5 because my system is exactly identical. Right. So, going further, R1, R3 coordination. For R3, I have to consider 1000 MVA now on bus A, PSM of R3, 7.29. On the same considerations, right? Here, full 1000 MVA will pass. Try to understand in R3. It will not be divided by 2 because the complete fault will go to the pit. जहाँ खड्डा बन गया है, where there is a pit, the complete water will flow into that. Therefore, 1000 MVA full, that is 1000 into 10 raised to 3 divided by root 3 into 132 into 1500, because 1500 is my PS, into 0.4, all these things I will have to do. That gives me 7.29. Top of R3, because of that, is 3 upon log PSM into TMS. TMS for R3 I have already found out. TMS of R3 has been found out as 0.2. So 0.2 if I consider, then my top of R3 is 0.6954. R1 0.25 further. So 0.9454. PSM of R1, same 1000 MVA. But here 1000 MVA is going to be divided by 2. So 1000 upon root 3 into 132 into not now 1500 because it is 200%. So 2000 and 2 divided by 2 I will have to do. So that takes me to 2.73. So TMS of R1 based on the same formula and same rules, or R2 also is 0.1374. I have to go a step higher. So I select 0.15. Right. So friends, this is directional overcurrent relay. How would you set the settings of the directional overcurrent relay? Summarizing the settings, R1 to R6, right? R7 is given. R7 is given. R7 TMS is given 0.15, right? And the plug setting we have calculated 100%. Right? R6 is 100% of 1 ampere, R5 100%, R4, R3 150%, R1, R2 200%. TMS we have calculated R5, R6 0.05, R3, R4 0.2, R1, R2 we have calculated earlier, R1, R2 is 0.15, so R1, R2 is 0.15. Ground relays we are going to do in the next tutorial class, so same table will be repeated when we come to ground relays. I have not touched ground relays here. So this is the summary of settings, my dear friends. So this is how we are coming to an end to this. So as I was telling to you, this is the 7th tutorial, 8, 9, 10, 11, right? 8th will be same parallel feeder ground relays. 9th will be interconnected relays, phase relays. 10th will be interconnected system ground relays, right? And 11th is going to be configuration of one typical numerical relay. Same system we will be taking, which we have taken in this example, but we will be considering different dynamism of the system, and then we will be using group settings of the relays. So that will be 11. There will be 11. Then probably some 6 or 7 tutorials will be on experiments. How you can design experiments in institutes. engineering institutions, degree and diploma. If you want to design simple experiments, if you want to simulate the feeders, transmission lines in laboratory, how you can do that, how you can calculate relay setting there, and how you can make the relays to operate, how you can see backup, everything, right? So that we have done. A very good laboratory has been developed at BVM Engineering College, Vallabh Vidyanagar, Birla Vishwakarma Mahavidyalaya. That laboratory was started in 86. In 88-89, it was completely ready. In 2002, we received another grant of some 12 lakhs of rupees, and we developed some experiments on numerical relays. So we developed some 60 experiments in that laboratory. It is a very well-known laboratory throughout Gujarat and throughout India. Many institutes in Gujarat state have copied this laboratory. That laboratory, in yet more professional sense, has been developed at PDPU, Pandit Dindayal Energy University, in School of Technology. And these experiments, and I have already written one uh, paper in IEEE transactions, power apparatus and systems, power delivery magazine, and it was published in 2005, that the laboratory can be developed and the students can be made to understand what really happens in the field. So there will be some 7 tutorials there, and then we'll be going to distance protection. In distance protection, once again, some 10, 11 tutorial videos will be there. So like that, if we pass on to protection of generator, protection of transformer, protection of induction motor, bus zone protection, right? CT and PT, testing of relays, right? And then if we go to circuit breaking theories, different types of circuit breakers, over voltage protection, right? And then if we touch to the numerical relay architecture and everything, then it should, I think, take me to some 100 such videos. So friends, be in touch with me, be in touch with me, remain in touch. Just go on, visit every day the YouTube videos, visit YouTube, search for me, and you will see many videos there. So please try to learn power system protection through these videos. It is my trial to share my best of my knowledge. Whatever I know, I want to share with all of my friends. I was doing it in institute, but that was limited to 60 students in BVM Engineering College. Then many engineering colleges started calling me as for expert talks. Many industries started calling me. But then the audience is 40, 50, 60, 100. I mean, it is not more than that. Here, through YouTube, I am trying to reach to lakhs and crores of people. It is up to you to, I mean, those who visit should go on sharing to their friends, subscribe the channel, like the videos, and share to as many friends as possible so that people learn, because there are very few professors, there are very few experts in the field of power system protection. In Gujarat, even India, well, there are few people, not very many people, who are knowing protection in its totality. So if you want to learn from an expert person, please share these videos. So friends, with that I come to an end, with a request to stay tuned with me. Remember this name, me. Ed means education, and it takes you up, take me up in terms of education. And I was telling in last tutorial that education is the only thing which is imparted, it increases. If you spend education, it increases in you. Vyaye krute vardhate eva nityam. न चोराहार्यम न च राजहार्यम न भातृभाज्यम न च भाराकारी व्यये कृते वर्धते एव नित्यम न चोराहार्यम. A thief cannot steal vidya. Thief can steal your money. Thief can steal your gold. Thief can steal your clothes. Thief cannot steal your vidya, your education, your knowledge. Nachoraharyam, nacharajaharyam. King cannot take your education, your knowledge away. Nacharajaharyam. Nabatrubhajyam. It is not, you cannot give it to your brother. Take half of the knowledge from me. You can share, that is a different thing. But you cannot give. Na bhatrubhajyam, na cha bharakari. उससे भार नहीं पड़ता. If you have lot of money, it is 10, it will tense you. Because you see, more money means it will tense you. Somebody will steal. कोई ले जाएगा. That is problematic. That's a bharakari. Vyaye krute vardhate vanityam. If you use, if you donate, if you share, your own knowledge will increase. My knowledge is increasing by teaching to you, by sharing with you. So do that. Remember the name Adapt Me. Stay tuned with Adapt Me, my friends. Thank you. Good day. Good night. Because it is 10:30 now. So I should say good night. Thank you, everybody.